Okay, so here we are. We're going to take a look at some items regarding inequalities. So first of all, when we talk about inequalities, we have less than, we have greater than, we have less than and equal to, and we have greater than and equal to. And let's call this one -1. So if I were to graph these, I would, again, for the first one, x is less than 1, I'm going to put my boundary point where the 1 is, and I'm not going to color it in because x is values that are less than 1 but not including 1. Okay? So, and less than 1 is this way. Okay? So that makes sense because, say for example, we are talking about 0, then if I substitute x for 0, 0 is less than 1, that makes sense. But if I try 1 is less than 1, that doesn't make sense. So for that reason, the boundary point stays open. Okay? Now, let's get rid of all that. And let's take a look at x is greater than 2. So I'm going to put my boundary point at 2, and x can be any number greater than 2, which is this way. Now, x cannot be equal to 2. If I substitute x with 2, I end up with this statement, which doesn't make sense. 2 is not greater than 2. So for that reason, the boundary point remains open. It's because that number is not included. Okay? Now let's go to our equal thans. So with these two, we can say open boundary point. Okay? Now with these next two, let's take a look at that. We have x is less than and equal to -2. So there's my -2, and x can be any number less than -2, but it can also be -2 this time. So we color in, we fill in the boundary point to show that it can be -2. And for the next one, x is greater than or equal to -1. So x can be numbers greater than -1 this time, but it can also be -1, so we're going to fill in the boundary point to show that. So these ones here have a shaded boundary point. Okay? Now we'll just clear that. Okay, now we're back. So let's take a look at a few issues around solving inequalities. When we're solving inequalities, we may have something like this. X minus 2 is greater than and equal to 5. Okay, so we want to have a statement at the end that x is greater than or equal to something in this case. So we need to do something about this -2. So our rules are the same as for when we solve equations. Okay, we're going to use the same value with the opposite operation, and we're going to do that to both sides. Okay, so x minus 2, and then we're adding 2, leaves me with x. 5 plus 2 is 7, and our inequality is the same. So now we can graph it and say x can be 7. It can also be numbers greater than 7, and there's the graph. Okay, let's try another one. If I have 4x is less than 12, 4x means 4 times x. So we need the same value with the opposite operation. The opposite of multiplication is division. So I'm going to divide by 4. So if I have x times 4 and then divided by 4, I'm left with x. And in this case, x is less than 3. So I'm going to put my boundary point at 3. X can be numbers less than 3. But because of this symbol, x cannot actually be 3. So this boundary point will not be filled. It will remain open. Okay? Now, one last thing that you need to be aware of is sometimes the coefficient is negative. Okay? Now, this is negative 3 times x, so I need to use the same value, which is negative 3, but I'm dividing by negative 3. Okay, and I'm going to do that to both sides. Now, whenever you multiply or divide in an inequality, and you multiply or divide by a negative, you need to flip the sign. So it was greater than and equal to, now it's going to be less than or equal to. So x times 3 divided by negative 3 gives me x. 9 divided by negative 3 is negative 3. So my inequality, my solution is x is less than and equal to negative 3. There's negative 3. This is less than negative 3. And because x can be negative 3, we fill it in. So when you're in this situation, when you're dividing or multiplying by a negative to solve an inequality, don't forget to flip the sign.